Hey, 8th graders, hope all of you guys are doing well. We are going to begin with our second part of our chapter in 23 with the planets. We are going to define what a planet is and also just talk about each one of the planets in a little bit of detail. First of all, we got to answer what is a planet. In 2005, a group of astronomers at the Mount Palomar Observatory in California were studying some routine telescope image of a field of stars. They discovered a small dot that changed positions very slowly over several photos. After further study, they came upon an astounding conclusion that threw modern astronomy into upheaval. They had discovered a 10th planet. Far beyond Pluto's orbit was an object that they thought was bigger than Pluto. They went on to discover two more objects similar in size to Pluto. As these discoveries accumulated, astronomers began to question what a planet really was. In 2006, the International Astronomical Union, or IAU, met to define and reclassify objects in our solar system. So, what did they define in 2006 as a planet? And why then did Pluto not become a planet? The characteristics were just determined that it has to orbit the sun, it has a spheric shape, it does not share space in its orbit with any object of significant size other than its moons. So, what happened to Pluto then? It's a dwarf planet because it orbits the sun, so therefore it would be kind of a planet, but because it's going to be nearly spherical or rigid, depending on what type of dwarf planet it is, and it can share their orbits with other bodies. That is one thing with Pluto, that it shared its orbits with other bodies that are not satellites. Also, it does not have enough mass or enough gravity to hold its own orbit. That's why Pluto is no longer considered a planet. So when it comes to other bodies in the solar system that aren't planets, what are they? Smaller solar system bodies, or SSB, is anything that we do not classify as a planet, dwarf planet, or moon. And we'll talk about those in our next video. Then we have classifications by properties of the planet. So we divide up our 8 planets into two groups mainly. We have our terrestrial planets, which are the inner planets. They are closer than the sun than the asteroid belt. So these are going to be the 4 closest planets to the sun. They're going to have about the same size and density as Earth, and that's where they get the name terrestrial planets or Earth-like planets. There's Mercury, Venus, Earth, and Mars are going to be our terrestrial planets, so the ones that are the closest to the sun. Then we have what are called the Jovian planets, and these are going to be much larger than Earth. They have low densities. That is because they're made of light elements, gases, and ices. They're actually called either ice or gas giants, depending on which ones you're talking about. So they are Jupiter, Saturn, Uranus, and Neptune. Then we have some classifications by position. We have inferior planets, which are going to be closer to the sun than they are to the Earth. So if a planet's closer to the sun than the Earth, they are going to be called inferior planets, and they are viewed from Earth, and they are never far from the sun. So that would leave the first 2 planets in that category of inferior planets, being closer to the sun than the Earth. Then we have transits, is a type of inferior planet, or something that an inferior planet does. It's going to be a black silhouette of a planet as they cross in front of the sun. If they are not inferior, they would be superior planets. They are farther from the sun than the Earth. They move slowly from west to east across the star field, and they have what is called retrograde motion. Retrograde motion is where they're going to appear to go backwards in the sky. They aren't actually going backwards. They are just, because of our position on Earth and where they are located, it looks like they are going backward. With retrograde motion, think of that as if you're on the highway and your parents are driving and you notice that the car you just passed looked like it was going backwards. Is that car truly going backwards? No, that car's not truly going backwards. It's just your speed's a little bit faster, so it looks like it was going backwards. The same thing happens in retrograde motion. It just has to do with appearance. It's not actually going backwards, though. Let's talk about the terrestrial planets next. Remember, those are the Earth-like planets. We have Mercury, which is the closest to the sun. It was named after the messenger of the Roman gods, Mercury. It is covered with craters and Maria. It kind of looks similar to the moon. It can only be seen in the night sky just approximately before dawn or just after dusk. It is the smallest of our planets, has the shortest year, and rotates slowly. Mercury's year is only about 1.5 Mercury days. It has no other moons. There was little known about Mercury until the Mariner 10 became the first spacecraft to reach it, and they realized it was a barren, dead surface. On Mercury, the temperatures can reach 430 degrees Celsius, which is hot enough to melt lead during the daytime, but at night it drops down to negative 170 degrees Celsius. The reason why this is significant is the fact that Mercury doesn't have an atmosphere that holds heat in like our atmosphere does. It holds heat in so our temperature doesn't drop at night. This is also going to make Mercury not the hottest planet in our solar system, even though it is the closest to the sun and getting the most radiation from the sun. Actually, the hottest planet will be Venus, which is the second planet from the sun. It was named after the goddess of love and beauty. It is the brightest object in the night sky. It's actually called the evening and morning star because they thought originally it was a star and it was one of the brightest objects in the night sky. It is our nearest neighbor. It is also, like I said, the hottest planet in the solar system because of the greenhouse effect. Due to the amount of greenhouse gases that are in its atmosphere, it traps in heat on Venus, so it becomes one of the hottest planets. One thing unique about Venus is that its rotation is going to spin backwards compared to other planets. As you can see in the picture, it rotates the opposite direction. This is also called retrograde rotation. So instead of the sun rising in the east and setting in the west, it's going to be opposite for Venus. Then we have Earth, and it's the third planet from the sun. We're not going to go into a huge amount of detail about Earth because we've talked about Earth so much throughout this book and this school year. Just know it's the third planet from the sun. Remember, it is 1 astronomical unit because that's the average distance between the sun and the Earth. Then we have Mars, which is our fourth planet from the sun, named after the god of war in mythology. It is the only terrestrial planet that is also a superior planet. Most of the terrestrial planets are going to be inferior. On the other hand, we have Mars, which is a superior planet. It is going to be easy to find in the night sky because it has a reddish color to it. It's going to be very similar to Earth in the fact that its day is only 40 minutes longer than an Earth day, has a similar rotation of its tilt of its axis. Mars has a tilt of 25.2 degrees, whereas Earth is 23.5. Mars is also going through seasonal changes as well. It also has a very wide variety of geological features that we see on Mars. There's plains, canyons, craters, volcanoes. The largest volcano in the solar system is actually located on Mars, called Olympus Mons. It also has a large rift valley that would be 4 times deeper than the Grand Canyon. Mars also has a couple of moons, which we'll talk about in a little bit. Then we have our Jovian planets. Our Jovian planets are going to be our outer planets. They're farther away from Earth. They're going to be just past the asteroid belt. Those are going to be our gas and ice giants, so they're going to be lighter, but they're also going to be a lot larger. These planets don't have solid surfaces to land on, like the other planets that we've talked about. Our first Jovian planet is Jupiter, which is the 5th planet from the Sun. It is the 3rd brightest non-luminescent body in the sky, just after the Moon and Venus. Remember, planets are going to reflect light, they don't produce light. One thing about Jupiter, it has this great red spot down here, which is a storm that has lasted for at least 3 centuries. How could it last that long? Compared to storms here on Earth, so like why doesn't our hurricanes, tornadoes last for centuries long? That's because on Earth there is solid surfaces with friction that can slow down the storm and stop it. Jupiter also has moons as well that were named after Galileo, who discovered them, so we call them the Galilean moons. You have Io, Europa, Ganymede, and Callisto. It's a picture of Io. Then we have Saturn, which is the 6th planet from the Sun. It is named after the Roman agricultural god, and it's nearly as bright as the brightest star we see. It is the 2nd most massive planet, which has a 95 times the mass of Earth. It has a density that is less than water, so if the entire planet was placed inside of a pool, it would float. It is considered the flattest or most oblate planet. It also has at least 62 moons that we know of. Largest is Titan, which is going to be larger than Mercury. Then we have Uranus, which is the 7th planet from the Sun. It was named after the Greek sky god. It was not recognizable to the ancient world because it's so faint and it was moving so slowly away. It was actually discovered in 1781 by Sir William Herschel with the optical telescope. It's called an ice giant because much of its atmosphere is going to be composed of ice. It is barely visible to the naked eye, so therefore it was unknown to the ancient astronomers. It was discovered in 1781. Little was known about it until the Voyager's 2 spacecraft flew by in the 1980s. Uranus is going to be unique because it spins on its side compared to the other planets. So its seasons are going to be very radical. They're going to be long, so it's going to have a continuous sunlight during this 20-year-long summer, and the other side of the planet is going to have 20 years of frigid cold temperatures. Neptune is going to be our most distant planet, and it was discovered by astronomers when they know that there was a pull exerted on Uranus, so it was our only planet that's been discovered by mathematical equations, then later proven when a satellite went past it, a spacecraft went past it. Alright, that is all for today. Here is a few things you guys need to know for your quiz that will be next week. Alright, let me know if you guys have any questions. Have a great day, guys.